microwave spectroscopy. Microwave spectroscopy means interaction of microwave radiation with matter is known as microwave spectroscopy. In this topic, we'll see the principle and selection rule of microwave spectroscopy and the expression of J, that is a rotational energy expression, and calculation of J for carbon monoxide molecule. Prior to that, we'll see what are the transitions. We know rotational, vibrational, and electronic transitions. Electronic transitions are higher energetic than vibrational. Vibrational energy transitions are higher energy than rotational. Now we are discussing only the transitions between these blue lines. Okay, J0 to J1, J1 to J2, or J2 to J1, or J1 to J0, like that. The transition between these two J levels, rotational energy level was indicated by J, vibrational transition level was indicated by V, and electronic transition was indicated by S. Okay. This is what a close view of rotational energy levels within vibrational levels, that is V0 to V1. We are having a number of J levels, that is J1 to J6, and still we will be having. Now we have to quantize these energy levels. What is the energy of J1 and J2? The gap between J1 and J2. What is the energy difference between J1 and J2, and J1 and J0, and J3 and J2? We have to quantize. For that, we have to consider the diatomic molecule as a rigid rotor model. Okay. So let us, and the principle of the microwave spectroscopy is the measurement of energy of the transition between the quantized rotational energy levels is in gas phase. Okay, this is what the principle of microwave spectroscopy. And selection rule. What is meant by selection rule? Like in vibrational spectroscopy, the selection rule or main requirement for the vibrational spectroscopy, del mu is not equal to 0. That means change in dipole moment should not be 0. That is what the selection rule. Here, in the similar manner, the selection rule for microwave spectroscopy is del J. What is meant by del J? A delta J. Okay. The difference between two rotational energy levels, consecutive rotational levels, that is del J. And del J should be plus or minus 1. What is this plus or minus is indicating? Whether electron can go from J0 to J1 or J1 to J2, okay, J3 to J4, like that. But electron cannot go from J0 to J5, J0 to J2, J0 to J4, like that. That means the difference in the rotational energy transition levels should be plus or minus 1. While if it is going from 0 to 1, it is called absorption. If it is coming from J1 to J0, that is del J equal to minus 1. That means, let us assume J0 to J1 it is going. What is the higher energy level? J1. J1 is a 1 and J0 is 0. 1 minus 0 is 1. Del J is plus 1. Okay. Now, if J1 to J0, if the electron is coming, let us J1 to J0, that means final minus initial we have to. That is what the thing. That means 0 minus 1. Del J will be minus 1. That means while emission del J is minus 1, while absorption del J is plus 1. You keep in mind the selection rule. What is the selection rule for rotational spectroscopy or microwave spectroscopy? Del J equal to plus or minus 1. Okay. Plus 1 is for absorption, minus is 1 for emission. Okay. Next, the microwave spectroscopy and the principle and the calculation of J or the energy difference between two rotational levels can be done by considering the molecule in diatomic and polyatomic, and we will apply a rigid rotor model for diatomic molecules first, and we will find out the energy difference between J1 and J2 and J3 and J2. Okay, so let us see the derivation, that is rigid rotor.